quick introduction, just follow me on Snapchat if you're not following me on Snapchat yet. That's it. Okay, so 2 years ago, in my company for our biggest client, we started publishing domain events. That was 2 years ago. And since that time, we publish millions of domain events. But frankly, when we started, I wasn't really sure, like, okay, why are we doing it? What are we going to, how are we going to benefit from that? What would we like to achieve? What is it for? But I decided to look at it with open mind and treat it as some kind of experiment, see how that plays out. And 2 years later, today now, I'm talking to you about Saga Pattern. So as you can probably guess, it went well. The experiment went well. And I want to have, when we go through the talk, it has a lot of code, a lot of knowledge. I want to like kill you with knowledge and code. And that's my style. I want you to remember that we started 2 years ago. So if you want to go next week to your project and start publishing domain events, you probably won't be able to use the Saga pattern that way. But maybe 2 years later you will be, or maybe faster thanks to knowing the things that I will present to you. So this presentation assumes that you have some kind of message-driven architecture in your system. And what does it mean? Usually it's called event-driven architecture. But I prefer the message-driven architecture naming because it emphasizes that there are two kinds of messages in your system, commands and events. And commands are things that the user comes to your system and requests that it should happen. So at the very beginning in your Rails project, this might be just params. But later, of course, the project evolves, everything complicates. You have big forms which are getting more and more complicated. So you introduce some kind of form objects, and that's cool. But when the project goes later, even more and more, and it's like 5 or 6 years old, and you have very, very complicated form objects, at some point you might realize that when the user actually submits one form, they're issuing multiple commands to your system, and you start to introducing the command objects to your architecture. And the example is, for example, you want to book a place, book a seat in a conference, and you decide, hey, I want to book this seat. And you issue a command. It has this seat name. It has some booking ID. It has conference or event ID. And this is the command. You want to take this place. You want to buy it. And when everything goes OK, when the service objects validates it, when this place is not taken, you can buy it, you have enough money, whatever, then we can publish an event. An event is something that happened, it occurred. So for example, when our booking process was successful, we can publish an event that entrance was booked. Okay, that's it. And the commands, they are usually issued by the users. They are viewing our website, interacting with them, and when they decide to do something, they issue a command. But what would happen? Imagine that the commands were not issued by the users, they were issued by the system itself. In that case, we would go to a Saga pattern. That's what we would do. And here's an example of a Saga pattern. So here's the situation in the system that I'm working on. It's a ticketing system that allows you to book tickets for a conference or event, festival, music, or so on. And we have this optional feature that you can get the tickets printed and delivered to you via physical postal mail. I know, it's very unusual. We are technical people. We don't get our tickets delivered by real mail. But we have this feature for some kind of people, and they actually like this feature. A few percentage of people buys that service. And here are the things that need to happen so that we send them actually the tickets through the mail. They need to add the service to the order. They must be willing. They need to fill out the address. We need to generate the PDF with the tickets. And they need to, of course, pay. Otherwise, why would we send them the tickets if they didn't pay? But here's an interesting thing. We don't know the order in which those things are going to happen. So, for example, we were wondering whether we should ask people for their address before or after they paid. We were afraid that if we ask them about the address, before they pay, then the conversion is going to be lower and the customer would drop out from the process. But we were also worried that if we ask them for the address after they pay, then maybe they are so happy that they bought the tickets that they close the browser or the tab in the browser and they will never fill out the details and we won't know where should we send those tickets to. And we decided to go with the second solution. We post this after because when they bought the tickets, they are motivated to give us the address. But here's the thing, we still don't know the exact orders of the events, because if there are a lot of people buying at this time and our background queues are a little stuck, then it might take a little time to generate the PDF. So with the help of browser autocomplete, you can fill out the postal address very quickly, like in a second or two, maybe even. But if you type manually your address and it's gonna take some time and there is no queue on the background, then the PDF is gonna come up faster. But our Saga deals with that. Whenever those 4 things occur for a given order, no matter the order in which they occurred, we issue the send PDF via postal. So we have 4 events that need to happen, and when those 4 events happen, the Saga is responsible for triggering the command, send PDF via postal. So this is where we are right now. But you might be wondering, okay, but what were the steps before you got there? How did the architecture, what was the evolution of the architecture so this is now possible? So here is the story. You start with just publishing events, nothing else. That's what you start. That's what you can start doing next week. Go home, install Rails event stored gem, and start publishing events. They will be saved in your database. So this is a very simple step. You have some kind of service, for example, register user service, and it registers the user, and then you publish an event, user registered by email. But don't give me your crude crap. It's not user created, user updated, or whatever. It's user registered by email. It's a different event than user joined from Facebook or user imported to your system. It's user registered by email. It's a meaningful name for what happened, and it's a very small event. It contains only 2 attributes, ID and email. Very simple. But sometimes the events will be much bigger. They can contain much more data, like 20 or 30 attributes. This can happen as well. Don't be scared of bigger events. But over those 2 and 3 years, I started to see that sometimes it might be that when the event has so many attributes, maybe you did 2 or 3 things in your system, and instead of sending 2, 3 events about what happened, you send one very big event instead. So sometimes it's okay, but also try to see whether it's not an indication that actually 2 or 3 things happened in your system. Okay. The next step, when you get familiar with the fact that you are publishing events and storing them in your database, is to introduce event handlers. When you're already comfortable that publishing events does not screw your application and everything is working okay. So here's a very simple event handler. It's simple because it only relies on the data that is in the published event. And this event handler is responsible for building a read model in Elasticsearch. And it sends email and ID and few other attributes of a customer when they registered. And it's used by the customer service, by our back office admins to find user based on some of attributes when they call them and they need help. So that's what the read model is about. It's a very simple event handler. And you can think about it as some kind of like active record callback, like after save or after update, after create, after commit, whatever. And except for one thing, they are meaningful. The events tell you what happened. When you are inside active record callback, you know that some data changed in your model, but you don't know for what reason, why, what happened. And the events are better in that way because they have meaningful names, like user registered by email, or ticket sold, or ticket generated, whatever. Whatever is the domain that you are working on right now. And sometimes you're gonna need a bit more complicated event handlers. So this event handler, when user is imported by a football club into our system because they decided to import season pass holder and start working with us instead of some different company, this handler checks out database to see whether we should give the imported users a standard welcome email or maybe a customized one for that particular customer. And we send them an email with a link so that they can set up a password. And the event handlers are great for things like API calls after something happened, mailers, notifications, metrics, and so on and so on. An interesting thing happened when we started to publish those events and introducing event handlers. I realized that in our code base, many times we had service objects that were taking multiple dependencies, like 5 or 6 objects as dependencies. But those dependencies were not there to help the service object decide whether a particular command can be executed or not. They were just interested in the fact that something happened. They were not there to help decide about something. They were not needed by the service object. They were just side effects. So user registered, and then 1, 2, 3, or 4 other parts of our system wanted to know that user registered. Because, for example, maybe they were invited by someone, and now they can join a party. Or maybe someone sent them tickets, and now when they registered, they can use those tickets on mobile device, and so on. But none of those things can prevent a user from registering. They are not there to help the service object decide whether a user can register or not. They are just there because they are interested in the fact that user registered. And they are great candidates to be moved into event handlers. So event store is this publish subscribe architecture in which you publish events, and the subscribers in DDD world are called handlers. And the only difference compared to normal publish subscribe architecture is that the events are also safe in database. So later you can use them for debugging, for audit log, or to figure out what actually happened. OK. At some point during working this project, you can realize that one handler can handle multiple different kinds of events. So here is an example. We have 2 very similarly sounding events: ticket refunded and ticket canceled by admin. At the beginning, they look like, well, what's the difference? They are almost identical. But you can look at the handlers that are connected to them. And ticket refunded has a few more handlers, because when the ticket is refunded, the money goes back to the customers. We need to update Salesforce that we now no longer have that amount of money. We need to update our reporting schema so that we know that we are a little less rich. And we need to release a given seat, for example, so that a different person can buy the seat again. But when the ticket is canceled by admin, none of those things happen. The reason for cancellation might be various. For example, you are misbehaving on a conference or something. It doesn't matter. What matters is that there is no money involved. You are not bringing this place back on sale. But in one context, in the scanner context, both of those events are handled in the same way. When the ticket is canceled and when it's refunded, the handler is invoking the revoked command. And what it does in a scanner-bounded context is that it no longer gives you access to the event. If someone tries to scan your ticket, it will be declined. It doesn't matter whether the ticket was canceled or refunded. When the ticket is scanned, it will be declined. And you might be wondering, why is the scanner in a ticketing application a separate bounded context at all? Why do we need to have like a subsystem only related for scanning? And the thing is that when you are working with big organizer, big events, and more complicated events like multi-day events or multi-venue events, or with stadium events, there are multiple rules when and what needs to happen so that your ticket can be scanned. It can be scanned on multiple days, so you need to be able to handle that. It can be scanned in multiple venues. And it might be that you need to use a specific entrance on a stadium to actually enter the event. And that's why scanner is a specific separate subsystem in our application, which is invoked from other parts. When ticket is refunded, tell scanner that they can no longer scan the tickets. Okay. And when your handler needs state to decide what to do next, then you've got yourself a Saga. So here is an example. This is a handler which reacts to 3 events: conference created, conference cloned, and ticket kind created. And when the conference is created or cloned based on a previous conference, what happens is that we store some data. We stored the tenant ID, the organizer ID, and we stored in a Boolean flag whether we issued a command. And when the second thing happens, when for the first time there's created a ticket, which is a paid kind of ticket. So the conference organizer created a ticket which allows the customers to actually pay for it. It's not a free ticket. Then we invoke a check bank setting command, which will check whether the organizer configured payouts and whether we, after the event, whether we can give them the money from the conference that they organized. But to do that, the handler needs data that was in the previous event. That's why we stored it in database. So when the conference was created or cloned, we stored some data in database. And then when the ticket is created, we issue a command based on the previous data that we have and maybe the data from this event. And then we store information that, OK, the command was triggered. We don't want to trigger it anymore. If they add 100 more tickets, we don't want to send 100 more emails if they haven't set up the bank settings. So this is a Saga. It needs 2 events to happen. And when both of them happen, it triggers a command at the end. Here's a different one. Order placed, order expired, and payment paid. In the ticketing industry, you have a limited amount of time to pay for the tickets, for example, half an hour in our case, because there may be a lot of demand, a lot of customers willing to pay for that Adele concert that you would like to go, and we can't wait indefinitely until you pay. But you can go to the payment website, and you can start filling out your data and become distracted. For example, your coworker or your wife might need your attention, and you skip the process, you take a few minutes, and then you come back later. But it turns out that the order expired. You didn't finish the full process in half an hour. But you fill out the payment details, and you pay, everything works OK, and you come back to our website informing us that, hey, I gave you my money. I paid. And we are like, sorry, but we don't have your order. And what do? We issue release payment command. So when those 3 things occur in our system, we issue a command to the payment part of our application that we don't want this money. Instead of capturing it, instead of taking it to our, release the money so that we don't have it. Give it back to the customer. OK, that's how Sagas work. So how would you implement a Saga? So first, let's discuss the synchronous handlers from Event Store. So the API that we built is very similar to REST API in that the handlers have a perform class method executed on them. And the reason for that is because we wanted our synchronous and asynchronous handlers which happen in the background to have a very similar API so that you can easily go from one to another. And usually the perform method initializes the handler class with some dependencies, and it calls the method call with the event that it received. And then it goes. In test, that's really nice because in test you can initialize the handler class yourself and pass some stubbed or mocked test dependencies and check what the method calls does. So that's why we do it this way. Okay. When you have synchronous handlers, it's important that you don't let the exceptions to bubble up. Why is that important? We have a service object here. It wraps the whole process within database transaction. So you register a user, and then you publish an event store, and this triggers the handler, which can publish something to Elasticsearch, for example. But the Elasticsearch might be down. It might not be working. It might not be fast enough, and there is an exception. And what do you do when the exception happens? Do you want to roll back this? Do you want to, like, the user was successfully registered, there were no problems with that. We just had a problem sending the user data to Elasticsearch. Should that trigger an exception which will bubble up and roll back the transaction, and in a result the user would not register? We don't want that. Because when you have multiple subsystems in your application, like one banded context, which is for payments, and one which is for search, and one which is for something different, when something occurs wrong in a small part of your system, that doesn't necessarily mean that every other part in your application is going to be worried about it. You can catch the exception, notify the developers, and let other parts of the application go their way. And when the developers come back and fix Elasticsearch, they can retry the handler and fix that small part of application. The exception does not need to roll back everything that happened. Okay. Later, you would probably want to start introducing asynchronous handlers in your application. So this is the very core of our event store publisher. And what it does is iterates over all the handlers registered for given event, and it's either based on the fact that the handler is asynchronous, puts them on REST queue, or it invokes the handler class immediately. And in both cases, we serialize the event using YAML, so the interface is identical in both cases. And it's not a perfect solution. It's just using REST. There is nothing fancy in it. But the simplicity is actually nice. We used what we already had in our system, and it let us move on. That was enough for us to have asynchronous sagas reacting in the background to events happening in our application. So this is the simplified version, because the reality is a bit more complicated. Because there's one situation that you would like to avoid. Imagine that you open a database transaction, you do something, you save the user, and you published an event that user was registered, and then some handler, asynchronous handler, can be triggered in a background job. And that handler might look into database and not find the user record because the database transaction on the application server was not yet committed. So we don't want to trigger asynchronous handlers until the transaction is committed. So we use the same interface that Active Record is using internally with after commit callbacks to actually track that kind of situations. And only when the transaction is committed, we send the async handlers to be executed on REST. Okay. You might be wondering, why are we serializing those events with YAML? That kind of not trendy, let's say. And the reason for that is that when we begin with our project, we weren't sure about the schema of our events, what attributes they're going to be. We didn't want to define them. Also, YAML is nice because without defining schema, you can serialize date or time objects, and when they are deserialized, it works automatically. It's not like JSON when you get a string, and when you deserialize, you get string instead of time. And you need to know that there was time inside to actually parse that string and make it a time. So That was very nice at the beginning. And also YAML is very good at serializing basic value objects. So if you have a struct, like seed in our use case has UUID and some name, it's a struct, you can just put it into YAML, serialize, deserialize, and you get a value object back. But 2-3 years later, now, when we rely so much on the events, they are becoming the core of our infrastructure, we started to introduce the schema of our events anyway, and now YAML is not so beneficial for us. So maybe we will go with JSON or message packed or protobuf, because we started to define the schema of events anyway. So this attribute must be string, another attribute must be integer, and then there is array of somethings having something else inside, because we rely on them so much. When the handler is asynchronous and happening in a background job, you can rewrite the exception. It has the nice fact that it will bubble up and show us in a REST interface that there was a failure. When you fix that kind of failure, you can easily retry it. Okay, and here is a challenging thing. So I said at the beginning that the events can happen in any order. We don't know exactly. But our Saga, to make a decision about them, needs to process them one by one, linearly. So it needs to make sure that it's only processing one event at the time and consuming them, because if we have like some kind of race condition, then we might not figure out that we should be calling some kind of command. So what do we do? Nothing fancy. We just use database logs to make sure that there's only one instance of that Saga running at the time and processing the events. So we use log, find or create. If the Saga state is already on database, it will log that record. So we know that we have exclusive log and only one thing is running at the time. And if the state is not yet on the database, then what saves us and makes this safe is that we have unique index on the Saga order ID, and so no two can be created at the same time. So we initialize the state of the Saga, for example, based on the order ID attribute that we have when order was created or something was added to an order. And then we need to process that event somehow. So what we usually do is we just call something on the state. So when the user decided to fill out the postal address and postal filled out handler was triggered, then we call state filled out. And what it does is it updates the state that the one thing happened, the postal address was filled out, it saves the state, and then all the other things that can happen, like the order was paid, it was added to the postal service was added to basket, or the PDF with tickets was generated, all they at the end call maybe send postal via API method. And this method checks if all the conditions actually were already met. So if it was paid, filled out, we have the PDF, it was added to basket, then we can call a command. The command that we are calling in this case is transmit the PDF using the uploader adapter. We have adapter to the postal service system. And that's it. That's how we call the command. But there is a problem with this solution. The problem is that we need to pass the adapter, the uploader, via this method. And all the other methods that we have, they also have this adapter that needs to be passed. And where is it passed from? It's passed from the handler. Here we have raise configuration postal adapter. So we are passing it, passing and passing, because in test we want to have a different kind of adapter. We don't want to send actual PDFs to people when we are testing this functionality, right? So that would trigger a lot of costs and mails. So we are passing it. But that's not really convenient. The Saga does not need to know who's going to react on this command and how to instantiate this service object or API adapter. So there's a better solution. And the solution is to introduce a command bus. So command bus is like a router which routes command in your system to the services that can handle them. And you already have a very similar solution in your Rails applications. It's called the router, the HTTP router. You configure your routes, and it knows when the user visits given URL, which controller should handle that. And command bus is just like that, but it's on a different layer. It's not on HTTP layer, it's on application layer. You give it a command, and you don't care which service object will handle it. You know there will be one, and the service object will handle that command, and it will either work or not. So at the beginning, I said that we have two kinds of messages, events and commands. And for events, you had the event store. You publish an event, it's saved in database as something that happened. It triggers the handlers. And for commands, you have the command bus, which you can use to trigger the commands and to be executed by certain service object without thinking which one would that be. It's decoupling what needs to be done. We need to send PDF via postal from who's capable of doing that. OK, that's more or less it. Thank you very much. Make events not crude. But there's one more story that I wanted to share with you. How many of you are doing any kind of open source, like even one commit, smallest things? Raise your hand. How many of you are doing open source? OK, that's good. And how many of you earn something on open source, like real money? Who paid you for doing open source? No one? Yeah, that's what I guessed. OK, so in my entire life, a few years ago, I made a project called Active Reload. It was used to speed up the development mode in Rails when it wasn't that fast. And later, it was added to Rails. And thousands of downloads it had. It speed up the development process for a lot of developers, and that's why it landed in Rails. And I asked for donations on a GitHub page, and well, $15 were donated to me in my entire life. And I spent this money on flowers for my wife. That's it. That's everything that I earned on open source. But last year, the company that I work for and write books with, RubyC, we made $50,000 on writing and selling books for programmers. $50,000. So if you're thinking like how to monetize your knowledge, maybe try to spend a little less time writing open source code and a little more time writing books for the developers and trying to give them the knowledge in terms of book. Because surprisingly, we as developers have a very hard problem giving someone $50 for their open source contribution, but we have no problem giving them $50 for the book that they wrote. It's an interesting fact. So if you like the talk, if you like what I'm doing on Snapchat, on Twitter, on the RubyC newsletter, when we give tons of knowledge for free, and you can support us by just going and buying one of the books that we have. But if you are not ready for that and you don't think that I gave you enough value, then just subscribe to newsletter and get free knowledge for years to come. And when you think, OK, they roll, this guy gave me enough knowledge to actually give them back some money, then you can buy our book again. That's it. Thank you.
Thank you, Robert.